Good afternoon and welcome to our presentation, Tips, Techniques, and Tools for ADAS and EV/hybrid capable wheel hub assemblies. My name is Andrew Markell. I'm the Director of Content for Babcock's Media's Tech Group and the presenter for today's event. Today's webinar is sponsored by the wonderful folks at BCA Bearings by NTN. Wheel hub assemblies are at the heart of two revolutionary vehicle technologies that could be disrupting your shop: electrification and advanced driver assistance systems, or ADAS. However, without wheel hubs that are producing a high-resolution wheel speed sensor signal, these technologies can't deliver on the promise of a better future. Next, I'd like to introduce my co-presenters from BCA. We're happy to have Matt Gorski joining us today. Matt is the Manager of Product Development for the automotive aftermarket for NTN Bearing Corporation of America. He started out in the automotive industry working as an automotive technician for 12 years before joining the automotive aftermarket as a technical trainer. Also, we have Patrick Cronin joining us today. Patrick has been with the automotive aftermarket with NTN for 6 years and knows the BCA bearing brand and the customers that of BCA. He currently serves as a marketing manager for the automotive aftermarket. Patrick is on the front lines communicating with technicians and DIYers and has gained valuable insights into the everyday challenges facing technicians installing hub bearings and also diagnosing some problems with wheel speed sensors. So let's get started with the presentation here. This is going to be a conversation. It's going to be a discussion between Patrick and Matt and myself. And it's not meant to be scare tactic training, which I've seen a lot lately. What it's going to do is it's going to give you an advantage in the marketplace to realize what's changing. How can you take advantage of it? What are the opportunities? And, it's not as scary as you think. So let's get started here. So the great thing about this, and this is why Matt and Patrick are here, is they're going to give the perspective of an aftermarket manufacturer who is also selling to the OE side of the market. And it's going to be a great perspective that will really kind of change your mind about some of the hub units and what's coming down the line. But basically, we're going to concentrate on electric, hybrid, and what's going on with those wheel bearings, troubleshooting wheel speed sensors and its impact on ADAS, and also hybrid and regenerative braking systems. We're going to go over some tools, techniques to servicing wheel bearings, and some things that you may want to buy, especially with some of the tools we have at the end here. And we're going to have some tips to replacing modern hub assemblies and insights into the future. So let's get rolling here. Patrick, we got a good survey. This is kind of interesting. Do you want to tee this one off?
Yeah, we wanted to start off and just kind of get a feeling for what's going on with our shops and techs in the audience here. So we wanted to ask right off the bat if your shop is currently servicing electric vehicles or hybrids. So the answers are we service hybrids but not EVs. We service EVs but not hybrids. We service both, or we service neither. So all the folks in the audience, we're going to tap into your experience right now off the bat. Like Andrew said, we don't want to scare anyone, but these electric vehicles, these more advanced hybrid vehicles, are coming to the aftermarket. Once they're out of their factory warranty, once they're on their second or third owner, a lot of these owners are going to be looking for independent repair facilities that can service their vehicles outside of the dealer network. So we want to get a feel for right now where we're at. And BCA as an automotive aftermarket brand, we're here to support the aftermarket, support our customers, the guys that are taking our products out of the box. So we've got the parts. And we've got the knowledge, the know-how to install them. So we want to be ready when you guys are ready. So thank you all for taking this opportunity to answer the poll question and let us know what we're dealing with.
It looks like almost a 60-40 split on this one.
And we've got, like I said, the next couple slides, we're gonna give you an idea of some other numbers here, but we wanted to kind of introduce you, give you a snapshot of like the last 10 years here, and the growth of the hybrid, the plug-in hybrid, the EV market in the U.S. We know hybrids have been around for 20, 25 years now. So it's no surprise that there's a lot of adoption with hybrid vehicles. Plug-in hybrids are growing in popularity along with the battery technology that also enables the electric vehicles, full electric. So as you can see, what do we say? It takes 4, 5, 7 years for these vehicles really to get into the sweet spot for the aftermarket. So you can kind of look back a few years and kind of see where we're at and where we're going.
Very interesting. It's interesting that the hybrids are still going to be around for a very long time.
Yeah, I think it's a gateway vehicle to the full electric, so people have got to ease into it so that they feel more comfortable with the range and just kind of letting go of the gas side of things.
Yeah, range anxiety is a big deal with electric vehicles. I have range anxiety and I don't even have an electric vehicle. So, all right. So here's as we move along, where we started and where we're going. It was 2012 that Tesla first introduced the Model S, the first mainstream a full electric sedan. Others have come before it. We know that Mitsubishi, that Nissan, and others had full electric vehicles, but we'll look at 2012, just over 10 years ago, and we've come quite a long ways. Another example, another interesting fun fact is that in 2019, the full electric vehicles outsold cars with manual transmissions for the first time. As you can see some of the numbers there. We know manuals have dropped in popularity. Some of us still like to row our own gears, but the EVs are now outselling manual transmissions. And then that final bullet point, this kind of interesting, is the 2024 model year Cadillac, the oldest, most traditional automaker from the big three, is releasing a flagship electric sedan, the Cadillac Celestiq, which comes with a starting price of about $340,000. So we've gone from one sedan, a full electric sedan on the market, and here we are 12 years later, and Cadillac's launching a $300,000 EV. So kind of gives you an idea of the breadth of the electric vehicle industry there, I think. And further proof that EVs are coming for the aftermarket is these are all of the EVs for sale in the U.S. for the 2024 model year. So as you can see there are dozens of new vehicles coming our way. So it's not just the Teslas, it's not just the $300,000 Cadillacs, but in the next few years there are dozens of new EVs coming to the market, and we're going to start seeing them on the roads and be wondering, what was that? That strange car with no grill. And it's going to be an EV of some sort.
Well, if they can keep the prices down and the volumes up, it should be a win.
All right. So now we can kind of circle back to our poll question, and we kind of wanted to put this in perspective. These results that you see here on this slide are from a Shop Owner magazine poll they conducted earlier this year. Keep in mind, this is nationwide. There are areas where hybrids or EVs are more popular. But as you can see, of the shops they surveyed that answered, 71% currently work on hybrid vehicles. 31% currently work on electric vehicles. So look at it this way. It took 25 years for that number to get to 71% for hybrid vehicles. And it will take quite a bit more time for EVs to become more mainstream and be working on in a lot of these independent shops. But we kind of thought that this was an interesting place to kind of start and dive into from the market as a whole and get into more what we're here to talk about today with wheel hubs.
And, we're going to be doing this survey probably for the next 2 decades just to see, what's the adoption rate. And it's definitely going to increase over the next couple of years here.
We're seeing in registered vehicles on the road that there's a higher number. In fact, they almost doubled in a year and a half as to what percentage of the vehicles on the road are hybrid versus electric. And we're seeing a migration away from some of the hybrids into the electric. So Tesla dominating about 85% of those vehicles on the road, but the downside of that is the lack of shared data from Tesla so that you guys can go in there and actually just pull up torque specs or wiring schematics or anything, which is another barrier that you guys are going to be facing out there. But hopefully with a little bit of luck, we'll have some right to repair information, and Tesla will release more and more information for the regular maintenance on vehicles.
And Patrick, you brought up a good point about the used car market. You know, a lot of these vehicles now have aged out into the used car market, and they're on their second owner.
Yeah, and that's going to help drive business to the independent repair folks out there, and the brave DIYers.
Yeah.
You know, but make sure they have the right repair information before they start taking parts off.
Great discussion. And, you know, we are always talking about, here are the facts, the figures, the survey, but to kind of look at the base of like what's really changing inside this market is we're seeing more and more technologies on the vehicle that are dependent on to know how fast the wheels are turning in every corner. And we're not just talking ABS, we're talking ADAS and then also electrification. We're also seeing heavier vehicles, which is good for our market as far as, more weight on the vehicles means more damage to the suspension, also more wear and tear to the brakes and other components on the vehicle. So that thanks to the wonderful battery packs in those vehicles. And we're seeing more concerns about fuel economy and range. And, sort of the great thing of it too is, we're seeing a lot of those ADAS and EV vehicles. I mean, most of the EV vehicles, everything from the Hyundai Ioniq to the Tesla, they seem to just have a lot of different ADAS features, everything from lane keeping to full autonomous steering.
That's right, Andrew. And with all these technologies, they're all feeding off of different sensors and taking data from different places and spitting them into an algorithm and outputting who knows what. But one of those sensors that's really important for all those systems is the wheel speed sensor. The vehicle needs to know how fast each wheel is turning, in very down to a very specific degree to be able to operate all those different ADAS and safety features.
And the performance of these vehicles with the instant torque off the line, it's just simply amazing.
Yeah, when we're talking today, we haven't begun to really see the impact of that on wheel hubs and the longevity of the wheel hubs. But we're seeing it, we're hearing about it with tires and other components that EVs might have different service intervals for some of those parts than what we're used to seeing. So some of that is still to be determined.
And from the OE side, when this all started years ago, a lot of these vehicles use the same hub assemblies as the gas-powered ones. And then we've had to make some tweaks and adjustments. It was a learning curve for us as well to see if we can raise the shoulder height or increase the rolling resistance due to steel contact area and ceramic versus steel ball hardening, all sorts of things that are involved. So it's a growth market and something that we're constantly improving upon.
I guess the bigger question is, what will change day to day at the shops with these vehicles coming into more prominence and as part of the vehicle park? I got to say, first off, it's going to be the parts. We're going to see wheel hubs with more content, if you really want to call it that, in the form of wheel speed sensors. They're going to be a little bit more complex. We're going to see orbital forming. So it's definitely going to be more technology at the wheel end. Also, labor. I mean, we're going to see additional steps to service these vehicles. And it's going to be torque specs. It's going to be, torque to yields things. It's going to be more to remove from the vehicle to service some of these parts. That's been coming up more and more. This is actually a Mazda 3, but it gives an indicative view of, what you're up against if you have to remove a wheel hub on a vehicle. But for the most part, it's going to stay the same. There's just going to be small changes that you just have to be aware of.
Yeah, that's right. I mean, the installation of a wheel hub really isn't going to change too much. There may be model-specific things you need to be aware of. If a good example of that is if a wheel speed sensor, some of them aren't attached to the wheel hub.
Yep.
And you need to.
There's different air gaps and stuff, but there's more shielding. in some of the ABS cords, there's definitely going to be galvanic corrosion issues because of the different material in the knuckles, and so we're looking at different types of coatings and anodizations that we do to the hubs so that we don't have any kind of arcing or short to ground type of situations, which you've obviously probably heard of in the past, where electricity is going to find its path to ground, and sometimes it's through the knuckle, through the balls, and trying to get to the ground. So we're looking at different ways to insulate and isolate that, but what it's really, from the bulk of what it is just the more precise the magnetic encoders and the number of poles, and the air gap tolerances are going to be a lot tighter. It's just going to be, they're built stronger to keep those tolerances, and there's less margin for error, I would say.
So, Matt, in terms of diagnostics, what should a technician, let's say they're looking at their training budget for the next 2 or 3 years, and they had to select certain courses that they should learn to help diagnose hybrid and EV vehicles. What would you advise them to take?
Of course, I always encourage anyone to take the basic electronics. There's advanced electronics and engine controls, and there's even some specific EV classes for not just the maintenance, but also diagnostic and how to trace down a wiring loom or a battery cell, or there's all sorts of things that I'm still actually learning. But just keep your eyes open and see if there's any community colleges, or if any suppliers are giving training on anything new and innovative. But as far as tools, of course, you're going to need your DVOM and an amp gauge and a clamp, and but information is key. You've got to have access to the latest and greatest, wiring diagrams and specifications and resistance values and all that stuff. So it's something that's definitely going to be an ongoing, a training issue for everyone.
Let's talk about ADAS. I think it's more related than anything else with electric and hybrid vehicles, and even modern vehicles going forward, probably for the next 5 to 10 years, is ADAS. And, we've really seen this influx of camera, radar sensors, and they seem to get all the attention. But still, it's the wheel speed sensor that's making a lot of the calls on a lot of this stuff, and it's involved in it, and it gives a little bit of redundancy for the system. But they're really having to look at the accuracy of some of these wheel speed sensors to keep up with stuff like automatic emergency braking, lane keeping, even blind spot detection. You wouldn't think that, but that plays off how fast the vehicle is traveling versus how close the other vehicle is. And here's my theory. I'm going to throw this out there, that with these systems, ADAS is a stepping stone to autonomous driving. So it's going to be interesting to see how these systems become more redundant and a little bit more robust, so they can meet those drivers' expectations.
And the good thing with wheel bearings, Andrew, is that they don't require the types of calibration that you're going to run into with cameras and radar. They're a lot of them, the air gap is going to be set from the factory. Mm-hmm. The wheel bearing end play is going to be set from the factory. So the installation of, as far as these advanced systems go, the wheel speed sensors probably going to be the most like a traditional vehicle.
Mm-hmm. Agreed.
And this is kind of interesting. This is off the Mercedes, I think it's the ESQ, their latest EV/autonomous, or whatever you want to call it, vehicle. It has 2 wheel speed sensors on the front. And I thought that was I haven't seen the service information on it yet, but I think that's kind of the direction that we're going in.
Yeah, and that's going to that's more and more common. That's something we see on our industrial side with more advanced robotic applications, where a bearing might need more than one speed sensor, one that's real accurate at low speeds, one that's more accurate at high speeds, and then kind of let the computers sort the difference out and deal with those signals. But yeah, multiple wheel speed sensors is definitely something we're going to see more of.
So kind of an interesting thing, I kind of went down the list of ADAS features that could be on a vehicle, and what sensor they depend on, which is typically the wheel speed sensor, along with other things on the vehicle, like lane keeping assist. It needs a reliable wheel speed sensor signal or information going to a couple different modules on the vehicle. Automatic emergency braking, wheel speed sensors, auto park. This is where we'll start talking about the active wheel speed sensor and the accuracy and how it can just, the smallest movement of the vehicle, it can detect the wheel speed or movement. Electric power steering. I mean, it's becoming tougher and tougher to find a hydraulic power steering, except on certain vehicles and certain categories. Active suspension, wheel speed sensors are used for that. The traditional ABS, ESC, traction control, still wheel speed sensors. But kind of interesting lately, TPMS, those are becoming more reliant on wheel speed sensors. If you look at some of the European manufacturers like BMW, Mercedes, they're essentially running two systems. So they have the direct pressure sensing inside the tire itself, but they're also looking at the high resolution wheel speed sensor data to determine if a blowout happens. So it's kind of an interesting system that they can detect a blowout faster with a wheel speed sensor than it could with a regular TPMS sensor. So this is really going to drive your diagnostics, not only, with the traditional wheel bearing replacement and hub unit replacement, but other categories too.
And for a more traditional vehicle without all these ADAS features, wheel speed sensor malfunctions, you get a light on the dash, the ABS light is on, maybe your ABS doesn't work, but, not a big deal, better get it into the shop. Once all these other systems stop working, it becomes more of an urgency for them to get it diagnosed, and more of an urgency for the techs out there to be able to identify what's causing their lane keeping assist to. I live in a suburban neighborhood here. The park down the street has a couple soccer fields. Last weekend there was a soccer tournament, and the cars come in the morning and they fill up down my residential street. Games start and stop, and people come and go, and you start to see people, these suburban soccer parents who might not necessarily parallel park on a regular basis. And you start to see them passing up spots because they don't want to parallel park. But then you see some people pull up and they,
hit a button,
let the car park on its own, and they're first in the front row seats for the soccer game. So, the more people become reliant on these systems, the more important it will be for them to have them all functioning properly. So, I should start recording people trying to parallel park on
your channel.
Get a couple cars behind them, starts the pressure heats up. So yeah, the lost art. The lost. Yeah.
Hey, we just had a question come in from Adan Gutierrez from Texas State Technical College. Thank you for attending, and hopefully you brought some students along with you. And he's wondering, what is the main cause of wheel speed sensor failure? Matt, I'll let you take this.
Well, there's two answers. One, if it's integral into the hub assembly, you're going to have bearing wear, which is going to cause the air gap to change. So as the bearing and the tolerances change, you're going to have a little more slop in there, which is going to change the air gap between the sensor and the encoder or the tone ring that's internal. And if it's external, like the speed sensor's mounted into the knuckle and reading off an encoder or tone ring that's on a CV axle or on a Gen 1 bearing, it's probably going to be, in my experience, it's contamination or road damage, if you will. You get rocks and pieces of metal and all sorts of other things that will attach themselves to some of the componentry, which can set off a light.
Well, thank you, Mr. Gutierrez, for that question. So we'll move on to our next slide, and we're kind of going to get into Mikey McCurdy's things in regards to how you test some of these wheel speed sensors. What you're going to be dealing with in the future, it's going to be an active wheel speed sensor. What is an active wheel speed sensor? Essentially, it is a digital sensor on the wheel that measures the movement of the teeth passing by. It's not generating voltage. It's not generating a signal that way. It's a digital signal. and it's very accurate, and it doesn't need to be going 3 to 7 miles an hour to work. And this is why that automatic parking thing Patrick was describing can work.
Yeah, that wouldn't work with a passive wheel speed sensor. You wouldn't have enough speed to generate the signal you need.
Mm-hmm.
So, and for anyone out there, since we're talking about wheel speed sensors and wiring harnesses, if you're looking for more information on it, check out the BCA YouTube channel, and you can go to our YouTube channel, to our website. We have a playlist on YouTube. It's probably 5 or 6 videos that speaks specifically to diagnosing wheel speed sensor issues, the differences between active and passive wheel speed sensors, probing wheel speed wiring harnesses, and a couple other videos. So much more in-depth information on this issue there.
But the basic parts of the sensor for most of them remain the same. You have a magnetic encoder ring that is embedded with magnets going north-south, 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 and that's how it measures the signal going past the air gap on the wheel speed sensor. The tone ring can be made of steel in some cases. Sensors are usually 2-wire, so you can't decide if it's a passive or an active sensor by the number of wires going to it. It may be 2 for the most part. But the most important thing to remember is that sensor has an integrated circuit inside. So what it's doing is it's taking in voltage. I know I'm going to get yelled at by some of the electrical people in one side, putting voltage to it. And then this transistor inside, as the teeth pass by the wheel speed sensor, it registers that. And it's sort of an interesting digital signal. It doesn't increase in overall height or voltage. It increases in frequency. And it's a square wave because it's essentially measuring those little wheel speed sensors going back and forth. Let me pull this up here, right at the either inside the wheel hub, on the side of the wheel hub, or in other locations for the vehicle. So what's the circuit? I think the first step in diagnosing anything in terms of a wheel speed sensor is to understand what the circuit is, where the wires go, what are the voltages on the circuit. And most wheel speed sensors will directly be wired into the ABS HCU or modulator on most vehicles. And that voltage going to the sensor itself may be anywhere between 3 to 12 volts, depending on the system and how it's configured. And it's a very simple, but some of these wires, we brought up wiring issues before. They're discrete wiring going all the way from like the rear corner of the vehicle all the way up to an ABS HCU underneath the hood. So you have to be aware that there could be issues, and depending on the voltage going through it, a little corrosion, as you said before, could cause that voltage to go down, and it could cause a issue with the signal itself. So what are the inputs and outputs of an active wheel speed sensor? Well, basically, it's taking voltage in and monitoring with the wheel speed sensor those magnets or the teeth going by it, and it's producing a signal. And this is kind of where we're going to get a little bit more advanced. I think this is kind of interesting with a scope. This is the signal. The blue one up top, that is a good signal. That's off of a vehicle. I think it's a General Motors product. And this is the wheel speed sensor being spun by hand. And we see it starting off slowly with the larger humps. And then as it goes faster, they get smaller and smaller as the magnets pass by the sensor itself. But how does this go wrong? And this actually comes from a General Motors TSB in regards to cleaning up these encoder rings. You see that one where it stays all the way at the top. Basically, it's telling the ABS HCU, hey, I'm not moving at all, but the wheel is actually moving. What that is it's magnetic debris stuck to the encoder ring. And this is from the General Motors TSB in regards to it. Looks pretty crusty. So that little chunk up there, that could cause that raise or that non-switching moment of the ABS HCU. And if you look at this, you could see it just repeating. It's regular. So that piece of metal is stuck to that encoder ring pretty hard.
And that's kind of what I was talking about, is that's one of the main reasons for one of the top 2 reasons why ABS lights come on is contamination of either the sensor or the encoder, or damage to a tone ring, or worn bearings.
And about the only way you could really spot this, you couldn't really do it with a scan tool, except this would probably generate a code. But with this approach with the scope, you can actually say it's probably going to be stuck to the encoder ring. by looking at the wheel speed sensor signal.
And another thing to just point out with this image here, Andrew, is we can see the wheel speed sensor is not attached to the wheel hub. It's kind of poking through there on the right side of the image.
Yep.
It's very important to know where that wheel speed sensor is so that you don't damage. Yeah, there we go. So that you don't damage it when you remove the wheel hub, because that's going to cause that could cause a whole host of other issues. Especially if you have to chase that wiring harness way up into the vehicle to replace it. So make sure you have the service information, you know what you're dealing with before you start pulling parts off.
Yeah. Some Nissans and Subarus have a shield, a tin shield on there that splits into, and if you just yank that hub off, you're going to snap the tip right off of that thing.
It's my policy now, after the lug nuts come off, the first thing I'm pulling on a wheel bearing job, it's going to be the wheel speed sensor on some vehicles.
Good practice. Good practice.
And we talked about codes from wheel speed sensors. Either they're erratic, open, implausible. That's another code you'll see in some of the descriptions for certain codes for wheel speed sensors. But this is where service information really starts to come in. And, you have that car with a code in it for a wheel speed sensor to understand what's happening with the vehicle. Every time a vehicle is started, keys put in the ignition, it initiates the start, it's testing all 4 circuits for the wheel speed sensors. And with that, it's sending out a bias voltage signal. So it knows if it applies a certain amount of voltage, thanks to the resistance in the circuit, it should be getting back. Again, I'm probably going to get yelled at by some of the electrical people that it doesn't really return voltage. That resistance or the amount of voltage drop equals a healthy circuit. If it's too much or too little, or there's an open in the circuit, it's going to set a code and disable the system. And with these, it's also checking the output of these sensors as the vehicle is moving and operating. So it's looking at a whole host of data. It's looking at the wheel speed sensor outputs on, miles per hour. It's matching those up. It's looking at what the driver's doing. It's even looking at the steering angle sensor on vehicles to see if it's in a turn. If that drop in the wheel speed is thanks to, the inside wheel going less distance than the outside wheel, it can look at that and analyze it and say, okay, this is normal. And if it happens on something else, this is abnormal. So it's a lot of data, and it's making a lot of safety critical decisions for the customer. Because the last thing, if you're an automaker or even a lawyer at their law firm, is an issue with the vehicle where the wheel speed sensor does not operate as it should, or it's taking erroneous data and then doing a correction off erroneous data. And this is where you get into the activation of systems when they're not really needed. But
yeah, and that's not unique to EVs or hybrids, but it is something that's going to be more of an issue because they have more different integrations with that sensor data. So
yeah, you can go into false brake modulation or ABS modulation and not set a code or not turn on a light. So and that's a safety related thing, which is something that some people struggle with. They're saying, well, the light's not on, but I'm going through this, the pedal drops to the floor when I come to a stop. So again, that's false modulation. So.
But you're going to find a lot of that stuff in the theory and operation of the service information for a lot of vehicles, except for Tesla. But for the customer, the complaints that you're going to be dealing with are going to be those that say, hey, my self-steering didn't activate or wouldn't let me use it. I was having issues with the Super Cruise on my General Motors SUV. It's going to be those alerts. And I saw this one recently on this is actually a Jeep product. So it says here, driving advisor failure. And this could be because of a wheel speed sensor circuit. And these are going to be complaints that you're going to start hearing from more and more customers that, hey, a feature didn't work on my vehicle, or hey, I knocked off a car on the freeway because my blind spot detection didn't work properly. So keep those in mind that, without a wheel speed sensor circuit or a code for one, you're going to have issues with the system.
Yeah, there's more and different symptoms for the same old issues.
More to go wrong, but it's a cascading effect. So, you can have an ABS light come on and disable so many different things. So in my experience, it's best just to pull the codes and take them on as they come out in order. and there's a logic to how they display the code. So, it may say if you've got this code with this code, go right, and if it doesn't have the secondary code, just stay left. So you're going to see a lot more of multiple codes that are linked together.
Worth mentioning here, Andrew, when you have customers coming in and they've got this, electric car, they're real techy, very proud of their vehicle. These types of customers are going to be looking for an OE quality replacement part. So I figured I'd put a plug in for BCA here. These customers are probably going to be less price conscious and more just wanting a premium part for their high-tech vehicle. So you can rest assured that a customer that's bringing an EV in is probably going to want to opt for the highest quality part with the OE technology, with the OE wheel speed sensors, things like that. So that's where you might want to push for the best and not the good or the better.
We've gone through what the waveform looks like. How do you connect to some of these circuits? Just to measure the resistance across it, which typically won't work too well with some of these active wheel speed sensors. So how do you probe these circuits? You could go in through the ABS HCU if you have the pinout for the connector. Sometimes that works, sometimes it doesn't. Sometimes they change it mid-model year of what the wires are going around. I've ran into that a couple times. It works sometimes. And you could back probe that. Typically, if you want to use a pin probe, a T-pin, as they call it, it could work there. But just make sure you're repairing that wiring harness, because any moisture that gets inside of these, since it's such a sensitive circuit, you got to be very careful. You typically don't want to use a lot of the more abusive methods, like some of the probes that will actually pierce the wire. So just keep that in mind. I like using bypass harnesses. Bypass harnesses, seem to work very well for hooking your scope into the circuit itself without causing any issues. Because remember, the second that you unplug that wheel speed sensor, it will generate a code if the key is on for that corner of the vehicle, and it will disable the wheel speed sensor. So in other words, you don't have that signal voltage going to the wheel speed sensor. So you need to create a bypass like this so you can monitor it. And even if you're lucky enough, you may even catch a bias voltage signal with your scope to see what's going on with the circuit. Sometimes I've used a low amp probe, haven't had too much luck with that, but it does work if you can have proper access to the wiring harness. Another method that it works sometimes is underneath some vehicles, at least for the rear wheel speed sensors, you'll have those connections there that you could swap the two to see if the wheel speed sensor code goes from left to right or right to left. That's mainly on Ford vehicles, it seems like, but I have seen it on some GMs. And this is on the back of a Ford Escape. So scan tools, let's talk about what a scan tool can do in some of these ADAS and also electrification systems in regards to wheel speed sensors. You can look at the codes, the data, the PIDs. You can actually look at the speed that the wheel speed sensor is generated, and that can give you an idea of if there's an issue with the wiring harness itself, an issue with how the sensor is being interpreted by the HCU. Top tip that I like to do sometimes if I have an erratic wheel speed sensor that drops out, you'll have that customer complaint, and the customer will say, hey, I had the ABS light all of a sudden come on after I was going over railroad tracks, a rough intersection, or I hit a manhole cover, and then I turned the key on, the code was gone. Sort of the neat thing with this, if Autel does it, Launch does it, I think even Bosch can do it, but you can graph the wheel speed sensors. So this one right here is 3 wheel speed sensor things, the 2 front and 1 rear. And this is essentially me doing a figure 8 in a parking lot. So you're able to see if there's a dropout. So let's say you're going for a test drive, you're going into a corner, and let's say that air gap all of a sudden increases and it causes a dropout in the signal. You'll be able to see that with a scan tool. And another thing that people forget about a scan tool is calibration and reflashing with some of these issues with the ABS system. It may be on a 3 or 4-year-old vehicle, but there are updates to the ADAS, ABS, any of those systems that rely on the wheel speed sensors. And with these, it can correct a lot of problems. A classic example is the Dodge Charger that was having issues with the ABS system on some of the police interceptors and how they ran those and how they drove those vehicles. There was an update. I've seen updates for other pedestrian vehicles. I think the Nissan Leaf has an update for the ABS HCU and also the pedal stroke simulator. These can help cure some of the problems that may come up in the field.
And being from an OE supplier, that's some of the stuff that as I was talking about earlier, stuff that we've learned after a vehicle or product's released, that we have to do tweaks or readjustments to the tolerances and the parameters in which it operates. So that's a good thing.
So let's talk about passive wheel speed sensors. They're out there. Typically on the rear wheels now. You won't find them on too many late model vehicles. And with these, they essentially generate AC voltage. And, man, I'm kind of curious. What vehicles would you say are most popular right now with passive wheel speed sensors? Most prevalent that have them?
Full-size trucks. Some of the bigger, less refined vehicles, I guess I would say. Some still have just a vehicle speed sensor in the rear axle, like you're showing the one that had three signals shown. So some will have a passive in the rear and active in the front. They're doing all sorts of things.
So this is the waveform that's generated, and it increases in overall voltage and also frequency as the teeth pass by the wheel speed sensor. And just like the active wheel speed sensor, instead of the magnet being in some of the encoder rings, it's actually on the tip of the sensor. And this is probably the worst one that I've ever seen. This one came up on a Lexus owners forum. Very interesting. And this could cause basically the signal to shrink down so it's not generating the same amount of voltage. And it could even skip out and see like it's missing teeth.
Yep, grinding brakes will do wonders to it.
You probably remember back in the early 2000s when you had all those complaints about the vehicles, the ABS activation. It was typically because there was
wipe off the sensor head and it goes away.
Patrick mentioned this earlier. Electrification. This is going to be the big push, and everybody thinks it's going to be, orange gloves and fancy insulated tools. But the reality of it is most of the stuff that if you're a normal shop, you're going to be you're already working on these systems, and it's the same stuff. BEV, battery electric vehicle, you're gonna see that acronym sometimes, plug-in hybrid electric, HEV, the normal hybrid that doesn't plug in. But all of these systems, it's 12-volt architecture. It's not 48, 32, or 400 volts. It is all pretty much 12 volts because, the suppliers of the systems don't want to engineer something for a very oddball voltage range. And it also makes service a lot easier too.
Especially working on a wheel hub, you're not going to be getting near anything high voltage.
As long as you stay away from the batteries, the inverters, and some of the high voltage stuff, you're fine. But for brakes and bearings and ball joints and tie rods, alignments, you're not going to come anywhere close to the high voltage stuff, or at least you shouldn't, if all the shields and everything are in place. That's something that's another thing that you got to take a look at when you get a used electric vehicle. Make sure that all the skid plates and protective shields are in place.
So the one place that actually Tesla does pretty decent on their service information website is some of the basic generic owner stuff. And this is basically the 12-volt fuse box on the vehicle. And kind of makes the point that, so much of this, the power steering, the ABS motor, the permanent power group, those are ones that are on the 12-volt. Even the HVAC is on 12 volts. So you already know about that one. So nothing special. So some of the challenges, again, we went through this before. It's the vehicle weight, it's the performance capabilities, the development of low friction seals to make sure that, all that drag or friction is out of the system so it operates properly. You also have regenerative braking, which is a whole nother thing with wheel speed sensors determining, how to actuate, number one, the regen cycle and when to switch over to hydraulic brakes. Also with, Hyundai Ioniq, Tesla, some of the GM vehicles, they're pretty ADAS intensive. So they throw, it seems like every single ADAS feature possible at some of these EV vehicles.
Yep.
But the number one thing I would say, if you're to concentrate on training, these vehicles, they have even more serial data buses than the normal vehicle because it's communicating between different systems. So get to know how to troubleshoot a CAN bus, even some of the more unique stuff like BMW has that fiber optic stuff, the FlexRay. That's going to be a critical skill in making sure a car can leave your shop without a code coming on for either the ADAS system or the electric system. So this is a classic example. Show that things really haven't changed that much. This is BCA's WE61960. This is for the S and X models for Tesla. And it goes on just like any other wheel bearing. Have you had a chance to do one of these yet, Matt?
Oh yeah. Yep. They're from the outside, they're gonna look exactly the same. The difference is gonna be in the interior steel design, bearing design, and then how many poles are going to be in that encoder. But other than that, it's going to serve just like any other hub. We do some anodizations and corrosion preventatives, but other than that, it's same old Gen 3.
And something interesting that you're going to see on these that you might have a question about is they're all going to be splined. You might have a single motor Tesla, which might be rear wheel drive or just front wheel drive. And you're going to have a splined hub on the other end that doesn't have an axle to go into it. So that's done intentionally. You didn't order the wrong part, but it makes things a lot simpler when all four corners uses the same wheel hub. So if you see splines and you don't have an axle to match it, you're still okay.
And again, that's not just unique to electric.
That's true.
That's been going on for many years, reduction of part numbers and OE part numbers. So,
well, we're coming near the end of the webinar, but please keep asking those questions. We're going to go into the Q&A here in just a little bit, just a few more slides to go. This is sort of an interesting one. We're going to do a guess the car or name the vehicle. This picture right here, if you take a look at it, interesting. You see drum brakes. It's basically an assembly for rear suspension. And you keep looking at this and you're like, drum brakes on an EV? It is an EV. I'll give you that. So,
I think we're a slide behind here, Andrew.
Oh, let me push that to the audience. Thank you, Patrick. So what is this? The Audi Q4, which is built off the VW Audi MBE platform. Curiously enough, Ford hasn't made this announcement, but it's definitely in the works. This is the next Ford Explorer EV. So the Audi Q4 will have the same drivetrain and technology behind it as the Ford Explorer. So this is something they did in collaboration. But the interesting thing is you look at this thing, this will blow you away. So it's a spherical ball bearing, integrated wheel speed sensor in there. It's also preloaded with a flange bolt. So this again drives home the point about quality and content in some of these wheel hub kits. Because typically, I think on some of the VW stuff already, BCA is including the flange bolt on some of the stuff.
And that flange bolt is doing a lot of work there. And that's where we again want to emphasize the importance of following torque specs to make sure that preload on the bearing is set properly, to make sure that everything is retained. But yeah, if you have a torque wrench and you have the specs, trust the specs. And
speaking of specs, we include a QR code or a torque spec guidebook in each box where there's an axle nut or a flange bolt that's needed to be torqued.
Yeah, so if you're dealing with a BCA part out of the box, we're going to give you the torque specs.
But it's kind of interesting with this one. It's a drum brake. Guys thought they were out of doing drum brakes, but Audi has brought it back.
Old as new again.
So Matt, let's talk tools with diagnosing wheel speed sensors and also service. Have you tried the ABS tester out yet?
I have a while back, and the one that I had experienced was a basic one, which would just tell you, it would send a source. You would disconnect the sensor from in the wheel well and plug it in, and it would send out the source signal and return signal, and it would do a self-test, if you will. And then you could just spin it, and it will, instead of showing a graph or a wave, it's got lights that'll tell you that it's good, bad dropouts. But those are no replacement for a good scope with graphing, or a good scan tool with graphing and scope capabilities. But,
It's a good first step.
it's a good first step, I guess, but
The low-hanging fruit.
it gives you the basic yes, no, red light, green light type of thing.
Which I think it's great because you can use it on lift with a system that's already disabled. You can spin the wheels, take a look at the information. It's great for systems that are already disabled.
Yeah, if it's a hard fault or something like that, then yes, it can be helpful.
Matt brought this before, the scope. There's a lot of content on here that you could really do on scopes, but we'll leave that for another one. But get used to your scope and learn to use it, because it will also work for other EV issues, and also ADAS issues too, and network issues.
That is the one piece of advice I'd want everyone to take away from this is learn how to use your tools and your scopes and library of known good patterns, and just build that workstation up so that you've got everything at your fingertips to properly diagnose and resource OE wiring schematics and specs.
So last but not least, your scan tool, and I'm going to give it a little bit of a top tool tip here. If you're looking to do ADAS calibrations and make that investment into a calibration, either from any manufacturer, there's a lot of them out there now. Look at the quality of the scan tool and what it can do, because typically, some of the mainline ones have a high end with all the software, including stuff for EV and ADAS on the scan tool that's attached to the fixtures. So you can kind of combine it in there, make a group purchase.
That's a big investment, yeah.
We're getting near the end here, and we're going to discuss. So, again, your torque wrench matters. I know we brought that up quite a bit. Thank you, Patrick. But yeah, just making sure you have the service information also.
And we have 3 videos on our YouTube channel that discuss the importance of torque specs and following them. So that's one of the top comebacks we see for wheel bearings, is improperly torqued wheel bearings. So make sure you pay attention to that. A couple quick things to move into for what's coming next. With the, NTN is an OE manufacturer, OE supplier of bearings. So we've always got new technologies in the pipeline, developing things like high-speed deep groove ball bearings for EVs and hybrids. A lot of these things are higher performing, more efficient, less friction, ultra low friction ball bearings for transmissions, tapered roller bearings for automotive transmissions that improve fuel efficiency. Every little bit, every percentage counts. It's not just wheel bearings, needle roller bearings for planetary reduction gears for EVs and hybrids. All these bearing technologies are going into the OE vehicles. So you can expect to see these in the aftermarket and in the BCA product line going forward. A couple other cool technologies here on this next slide is more EV related. You'll see hubs that are super efficient hubs that also have steering capabilities built into them. Now, these are future mobility type of things where you see these pictures of very complex looking hub assemblies. But these technologies all trickle down to the automotive OEs and to the aftermarket. That last bullet point there is something that's already on the market. You're seeing them, you don't even know it because it looks the same as a regular hub, but NTN developed a low friction hub bearing. NTN originated the triple lip seal, a huge advance of wheel hub seal technology. And triple lip seals introduce a little more friction maybe than we need nowadays. So with improved seal technology, improved engineering, we're able to develop even more efficient seals, less friction, more efficiency. So you can see we reduce rotational friction and improve fuel efficiency. Now, 0.53% improved fuel efficiency might not sound like a whole lot, but every little bit counts. And that does the bearing preload we talk about, where the balls or rolling elements ride on the races, is very important. The development in grease technology is important, and we already mentioned that improved seal design to also reduce friction. So these are all things that are coming to the aftermarket.
And hey, we're getting near the end. One last slide here. Looking at the future, again, wheel speed sensors and hub units. If they're not healthy, the vehicle's not healthy, both on the electric or ADAS front. That's, and this is something you're working right now on an internal combustion vehicle. So, a lot of this transfers to the future. So don't be scared. We're going to start moving into the Q&A. We've got some great questions coming from the audience. Thank you, Matt. Thank you, Patrick. This has been great information. They're going to join us for the Q&A session.
And if you don't have a question, but you do have something to share, we encourage that too.
Yeah, reach out to us.
I'd like to hear back some of your stories.
BCA website, you can get our contact information. You can go to the Ask Matt page, BCA Bearing/Ask Matt, to submit questions directly to Matt Gorski. We will get back to you on those.
Question that just came up. This is kind of interesting. This gentleman was wondering, who do you supply, which OEs do you supply to?
Well, technically and legally, we can't say. We have agreements with them, but they're on, if you drive by any major automotive dealership, it's going to be pretty much all of them.
Yeah, we're not allowed to disclose who NTN provides OE parts for. We can tell you that we're the largest supplier of OE hubs globally. We provide about 35% of OE wheel hubs globally from 84 factories around the world. So we're an OE supplier for the Asian market, for Europe, for North America. Wherever OE vehicles are made, you will find NTN hard at work. So,
another question that came from Dave Schneider at AIT. He is wondering, are we going to see more hubs containing ABS rings or the axle having a ring?
I don't think so. I think that the trend moving forward is going to be more, because you're going to have exposed encoders and then you have encapsulated encoders, depending on the design type. But I got a feeling that we're going to be sticking with magnetic encoders for the active style of sensors. It's going to be required for them to play nice with the other systems. And it's just a more protected and sealed type of unit, and not as much road and ozone and damage. I mean, we're bouncing around out in the wheel ends there, where you get all sorts of debris and rocks and curb strikes and stuff. So the more we can protect that stuff, the better.
We just had a question. What is the recommended cleaning procedure in regards to, I think he's referring to this slide right here with the metal on the encoder ring?
On the encoder ring, I would say replacement. I mean, depending, this is an extreme case, of course, but in some cases you can, just take a little bit of brake clean or a degreaser and just wipe it off with the shop rag. You don't have to go crazy with any brushes or anything like that. But unfortunately, what you're going to see is when it gets this bad, sometimes the integrity of the shielding, the outside sealing of the encoder to the outside environment is going to be degraded and exposed. So I think the more you pick at it, the more it's going to bleed, and sometimes it's just best to replace the part.
Yeah, a good rule of thumb is if it looks like it's been at the bottom of the ocean for 100 years,
Leave it there.
Probably due for replacement.
Yeah, and some of the GM bulletins are replacement, and then you put a cap. There's a plastic or metal tin cap that protects that in the future to encapsulate a little better.
But those seals do a lot of work. The seal is the unsung hero of the wheel end. They keep the grease in, they keep the contaminants out.
Contain the magnetic poles for the encoders. So
anything goes wrong there, it's going to be a failure.
Mm-hmm.
Well, Matthew, Patrick, we're 7 minutes over here, but I'd like to thank BCA for sponsoring this webinar. I'd like to thank Matthew and Patrick from BCA for making this webinar possible and giving us a whole new perspective, especially from the OE side of the business and aftermarket and engineering on hub units, ADAS, and EV. Thank you, guys. You got anything to add?
No, just thanks for your help, and thanks everyone for tuning in and being a part of this.
Yeah, apologies for running a bit long. Wish we could get to all your questions, but we'll get back to you. And also, definitely check out the BCA website for tech tips videos. Check out our YouTube page. Follow us on social, and stay in touch. We're here to support the aftermarket, and that's you guys out there. So thank you all.
Thank you.
What's the website again, Patrick?
BCAbearings.com.
Awesome. Well, thank you guys, and thank you to the audience for joining us this afternoon. And have a great day.